is this guy right here. Now, this is a picture here of Uncle Frank from Thanksgiving. No, actually, it's a picture of a Neanderthal, as one imagines they might be. And we've talked a lot about Neanderthals over the last few years and new results related to them. As you know, they disappeared from the planet around 40,000 years ago. And much of conventional wisdom was that we had killed them, that as Homo sapiens moved out of Africa into the regions where Neanderthals occupied, that in one way or another, either directly or indirectly, we had led to their demise. What's interesting to me is that there's a new study that suggests that perhaps they died due to simply bad luck. They were in the wrong place at the wrong time. The population at around the time they died out was between 10 and 70,000 when Homo sapiens began to come into Europe. And a new study, a Dutch study done out of Eindhoven University, looks at three different factors. Inbreeding, which we know there was, I think, by genetic sampling. Also, limited mate choice. If the groups are too small, then you have limited choices to mate with, and also if you have too few people to go hunting. And also there are natural fluctuations that take place in birth rates and death rates, and also the sex ratios of male to female. Now, what this group did, who did this study and looked at the numerics of what could have happened to Neanderthals, they actually used the statistics that we know of with humans, which of course may be a little suspect. But applying that, what they discovered was there was a reasonable chance that, in fact, the Neanderthals just died out on their own. Bad luck. Too few of them around in too few small groups, and as a result of inbreeding, limited mate selection, and other fluctuations in birth and death rates, it's quite possible that the population that might have been 10,000 would have dropped to zero naturally. Now, the one thing that these people do suggest is that it was probably exacerbated a little bit by the influx of Homo sapiens, not necessarily because the Homo sapiens killed the Neanderthals, but as they came in, the Neanderthal populations would spread out, and therefore they become even more isolated in smaller groups, exacerbating that fact. So the bottom line is that Neanderthals could have died out not due to us, but just because of bad luck, which makes the Neanderthals like many other species. You have to remember that of all hominid species, 10 or 12 of them at least, only one is not extinct now. All the rest have gone extinct. And 99% of all animals that have ever lived have gone extinct. Going extinct is the norm. So if Neanderthals went extinct, which they did, it may not have been directly due to us. But this leads me to the next topic I want to talk about, which is the future, and thinking about New Year's resolutions. We think of the Neanderthals having died out because of bad luck. And the question is, will we die out? And will it be bad luck? And if it is it the bad luck of being human? And in that regard, there's a new study which is rather sobering, and it has to do with our future. And it has to do with a study that was done by a group of, that reported in Nature, a group of 7 different scientists from Germany and Sweden and England and Australia, looking at the possibilities for major risks due to climate change. Not just small ones, but major ones. And as you can see from this slide here, the first thing they point out is that they're talking about basically global catastrophes, global tipping points, things that are irreversible, that once they're gone, they can't go back. And the first thing they notice is, as you look at the year of the International Panel on Climate Change studies from 2001 to 2007, 2013, 2018, the possibility of major risks goes down in temperature. Namely, in 2001, it was assumed that you'd need at least a 5 degrees centigrade temperature increase before you had a reasonable possibility or a reasonable risk of producing one of several global tipping points that we'll talk about. Then that went down to 4 degrees, and then 3 degrees, and the most recent study, in fact that's coming out now, suggests between 1.5 and 2 degrees we will already be at high risk for global tipping points. Now, I remind you that the Paris Climate Accords wanted to keep us to within 2 to 3 degrees centigrade, and we've already probably increased by 1 degree centigrade since pre-industrial times. And so we're talking about a very small range of temperature that we can still go to before some of these effects come in. And I want to talk about the effects that they enumerated. There's a whole slew of them, but some of them we've alluded to a little bit before. The first one I want to talk about has to do with Antarctic, which is that big mass at the bottom. It's big just because of the projection of the globe as it's done here. But of course, as I've talked about before, the Antarctic ice sheets are melting, and in particular, there's evidence that the West Antarctic ice sheet will actually get to the point of total collapse. And if the West Antarctic ice sheet, labeled I in this figure here, collapses, it will increase global sea levels within a century by 3 meters. 3 meters, 9.5 or 10 feet. This has occurred in the past. That's the other thing. Looking at paleoclimate studies of Antarctica, the disappearance of that ice sheet has happened in the past. So this is not some hypothetical thing that may happen in the future. At the same time, Greenland ice sheet is melting at an increasing rate. I've shown pictures of this before. A recent study just that I saw this week looked at one particular stream that was removing ice into water at a huge level, and it said 3 Olympic swimming pools are being removed every second from the ice due to that one stream alone. If the entire ice sheet in Greenland were to melt, if we went to that global tipping point, global sea levels will go up by 7 meters. 7 meters. Now, it's even worse because it's accelerating for a variety of reasons, but one of the reasons it's accelerating, as the ice sheet melts, the level of the top of the ice sheet goes down and gets closer to sea level where the air is warmer, and that causes it to melt faster. So there are several factors that cause that to get faster, and we're already talking about getting to 1.5 degrees above pre-industrial levels by the year 2030. And so if we're at a level where that global tipping point in Greenland ice begins to happen by 2030, that's a disaster. We're talking about 10 meters. 10 meters, and that between the West Antarctic ice sheet and the Greenland ice sheet, and that would take place over a century to a millennium, or maybe longer. Now, this is one of the points that's really important. It may sound like it's hopeless. We're gone. There's nothing much we can do. Sell your coastal property now. But the important thing is, it depends how big the temperature rise is. As these authors point out, if we hold the temperature rise to 1.5 degrees Celsius, then it might take 10,000 years for these effects to kick in. If we go above 2 degrees Celsius, it might take less than 1,000 years or a few centuries. And so what we need to do is think about reducing the increase in global temperatures, not necessarily to head off things which may be inevitable, and I want to talk about the various things that they say may be inevitable, but to try and push them back and maybe to lead to other mediation techniques. Now, one of the global tipping points that's already beginning to be seen is in Arctic ice. At 2 degrees Celsius, it's argued there's a 35% chance that the Arctic will be ice-free every summer, completely ice-free. That has an effect, as we'll see, because these different global tipping points relate to each other, because as the Arctic is ice-free, the albedo of the Earth, its ability to reflect light from the sun, changes. So let's go through some of the things that are discussed here. There's biosphere tipping points. The first one, in fact, is already being seen, and I think I have a picture of it here, which is well known if you're a scuba diver and you're going near Australia. You see coral bleaching. The coral here is white instead of multicolored, and this is one of the largest underwater ecosystems, and this bleaching is killing off mass amounts of coral. Whether they can come back or not is an open question, but it's pointed out that ocean acidification and warming at a level of 2 degrees Celsius is likely to kill off 99% of all underwater coral in the Earth. That's remarkable. But there are other effects, and we're seeing now politically, as a new leader of Brazil talks about burning the forest to make way for industries, and laughs at people who are worried about the ecology. The deforestation in the Amazon could get to a level of destabilization if you get to 40% removal of those forests. That whole system could collapse. We're already at 17%, and so we're not that far away. In fact, it's argued that destabilization could take place with as little as 20% of the Amazon being deforested. Then there's boreal forests in North America and the Arctic. We've already seen huge influx of insect disturbance and fires in California and elsewhere. That's likely to exacerbate. And that means that these forest regions, due to fires and dying trees, could be net carbon sources, not net carbon sinks. Normally, trees are carbon sink because they absorb carbon dioxide. But when they die off or burn, they become carbon sources. And if that happens on a grand scale, you'll get a huge burst of carbon dioxide in the atmosphere due to that. Another big concern, which is shown here in H, is permafrost. Permafrost in Siberia and other parts of the Arctic right now holds in a lot of CO2, and particularly methane, which is a huge greenhouse gas. It's 30 times more efficient a greenhouse gas than carbon dioxide. And if the permafrost melts, there'll be a huge burst of methane and carbon dioxide, and that could increase temperatures by a large amount in the period of a century. So the question is, can we stay within 1.5 degrees with a 50-50 chance, given today where we are? When you think about this and you turn it into a carbon dioxide budget, this means we have to release between now and the future less than 500 gigatons of carbon dioxide. If the permafrost melts, it'll release 100 gigatons of carbon dioxide. If the Amazon dies off, it'll release 90 gigatons of carbon dioxide. And if boreal forests die off and have fires, they'll release 110 gigatons of carbon dioxide. That leaves, when you take out those things, 200 gigatons that we can control directly. But right now, we on Earth are producing 40 gigatons of carbon dioxide in the atmosphere. If you work that out at the current rate, that means 5 years. We basically, in 5 years, could end up using up our entire budget of carbon dioxide before we are at risk of producing one of these global tipping points. And it's even worse, as these authors point out, because these tipping points affect each other. They've looked at 30 different global possible tipping points, and each one impacts on the other. For example, as I said, melting of Arctic sea ice will change the albedo, which will increase warming. Also, Arctic warming and Greenland ice melting will change the ocean currents, as they already are, but will change the Atlantic Ocean currents, and that'll have a number of effects. It'll destabilize, first of all, it'll destabilize African monsoons, producing large droughts in Africa in the Sahara. It'll also lead to drying of the Amazon, which will increase the likelihood that the Amazon will be destabilized. It will also heat the Southern Ocean, and the Southern Ocean being heated will increase the possibility that the West Antarctic ice sheets will collapse. So that all of these things work together. And as the authors point out, if we look at the paleohistory of the climate, these tipping points have happened before. And we've seen ice ages and ending of ice ages where basically the total climate on Earth has changed dramatically. And the interesting thing is that we are pumping carbon dioxide in the atmosphere and producing a temperature increase that is at a rate of 10 times faster than anything that happened when the glaciers melted at the end of the last ice age. The atmospheric CO2 right now is higher than it's been in the last 4 million years. If we continue on our current trend, it'll be higher than it was in the last 50 million years, back to the Eocene, where the temperature of the Earth was 14 degrees Celsius higher. And this means that when we look at the new IPCC report that's coming out in 2021, that we have to look not just at the small effects, but possible global tipping point effects. And all of this is highly speculative, one should point out, as these authors point out. But when they multiply the likelihood times the risk factor, any of these global effects, the risks are so huge for human population that you have to say that even if they've got a relatively small likelihood, when you multiply the two together, it means we have to take this thing seriously. We have to act now. And some of these things we may not be able to head off, but as they point out, if we can reduce the amount of carbon dioxide we're pumping in the atmosphere, so we reduce the global temperature increase in the Earth, we can push back the period over which some of these effects will happen to many millennia instead of centuries or less than a century. So the New Year's resolution we have to have as a result of all this is that we have to start taking care of the planet and thinking more carefully about these effects and realizing that not just having a better climate in the north part of Canada is a result of climate change, but there are global effects that can affect all of humanity. Okay, that's the negative part of the New Year's resolution. The last thing I want to talk about is the positive part, which comes from people who are actually thinking about doing things in the future. And in this case, I thought I'd talk, both NASA and the European Space Agency have talked about their plans for new projects in the next decade, which I thought I'd just summarize some of them because there's some exciting work going on. And one of them is NASA's announced a new Mars rover that's going to launch in July 2020, and it will explore, looking for the possibility of life on Mars, and so that's one of its first projects. As you've probably heard, there's big talk about humans going back to the moon. The current U.S. administration has argued they'll get there by 2024. How they'll do it, no one knows. But there are discussions about creating bases on the moon, learning how to live on the moon, and maybe even exploiting some of the resources of the moon, although I think that's unlikely. But certainly in the next decade, it's likely we'll return with humans to the moon. NASA is sending unmanned spacecraft out to do interesting things. This is an artist rendering of the Lucy spacecraft, which is going to fly by an asteroid in the asteroid belt, and it's going to look at 6 different Trojan asteroids to learn about the formation of asteroids and the early solar system, and ultimately the formation of planet Earth. One of the things we've been waiting for, because it's been pushed back and pushed back, it's now planned to be launched in 2021, is the James Webb Space Telescope, which is going to replace the Hubble Space Telescope, and it's hopefully going to be launched in 2021. It's got 100 times basically the power of the Hubble Space Telescope, and as I've talked about, it's going to allow us to look back to the formation of the first structures, the first light in the universe, to tell us about the origins of basically stars, galaxies, and many other things, as well as doing some planet hunting. And if all goes well, it'll launch in 2021. In the 2020s, although the date isn't exactly set, NASA is planning to send a mission to Europa, not to land on Europa, but as we've talked about, Europa has basically geysers coming from probably a salt ocean under Europa, and this Europa Clipper, as it's going to be called, is going to skim the surface of Europa less than 16 miles from its surface and go through those geysers and hopefully be able to probe the nature of that salt water and look for any traces of organic materials, etc. So that's a definite mission in the 2020s. Another big mission that NASA is going to send out is called WFIRST, which is the Wide Field Infrared Telescope, and it's going to have a field of view that's huge compared to the Hubble Space Telescope. It's going to be worth 100 Hubble images, but more than that, it will look at something like 1 billion galaxies, but because it's infrared, it's also going to be a planet hunter. And it's expected to find at least 3,000 new exoplanets. Again, exoplanets are going to be, as I talked about in an earlier episode, which they won the Nobel Prize this year, they're basically the future, because as we look for planets outside our solar system, we're going to be studying in more and more intense ways whether we can find for the existence of life elsewhere in the universe. And WFIRST will lead to that. Another thing that NASA is going to do, which may be relevant to the future of humanity, is a NEOCAM asteroid hunting mission. As is well known, asteroids impacting on the Earth has resulted in large-scale extinctions, including the extinction of the dinosaurs 65 million years ago. And we have the technology and principle to do 2 things. First, to search out with advance notice for any large asteroid which may be on an Earth-crossing trajectory, and then potentially to be able to do something about it. The first step is to look for asteroids, and NASA by 2025 is planning a large-scale satellite to basically map all the asteroids on Earth crossing trajectories. But that's going to be supplemented not by NASA, but by the European Space Agency. The European Space Agency recently announced a 45% increase in their budget, which if you live in the United States is just unheard of for fundamental science. And their budget at $12 or $13 billion is approaching NASA's. And in my opinion, the European Space Agency is fast approaching and may eclipse NASA as the #1 most important space mission agency in the world. And this first mission, which is planned for launch in 2020, is called the Euclid spacecraft. It's a pure scientific mission in a sense. It's going to look and try and map the dark energy and dark matter that dominates the universe, so we can try and figure out what it may be and what the future of the universe may be as a result of it. Another scientific mission they're planning to launch, which is going to complement the Earth-based gravitational wave observatories. Now there's new funding for the LISA mission, which is a space-based interferometer, which, as I've said before, the length of the interferometer arms in the LIGO mission is 4 kilometers, and we're already seeing gravitational waves from black hole collisions. LISA, if it's built in space, is going to have a lever arm of perhaps 4 million kilometers. It'll be much more powerful and be able to look for very different types of gravitational waves, including possible collisions of supermassive black holes at the centers of galaxies, and maybe, just maybe, a signal of gravitational waves in the long run from the very beginning of time. They're also going to have a new X-ray telescope, which will complement the gravitational wave observatories that we now have. It's going to be launched by 2030 or 2031. And when these large collisions occur that produce gravitational waves of neutron stars and other things, they'll produce X-rays, which this mission will be able to detect. But one of the other missions, this isn't it, I thought it was a picture of it, but one of the other missions that's now been funded is a program that will complement NASA's program to look at asteroids. It's a program called HERA, and it will observe the effects of something NASA's planning to do. NASA's planning to send a mission to an asteroid called Didymos in 2022 and collide with it to look at the possibility of redirecting asteroids that are on Earth-crossing trajectory. So if we hit them early enough, we can deflect them away from the Earth. And ESA will now be able to send up a mission that can closely observe what's happening so that we can potentially plan to save all of humanity. So while the Neanderthals died of bad luck because of the factors I talked about, we don't want to die because of bad luck because of an asteroid. And these complementary missions between NASA and the European Space Agency will go a long way to ultimately protecting us from something that is going to happen, whether it happens 1 million years in the future, 60 million years in the future, or sooner. A large Earth-crossing asteroid would potentially produce a massive extinction, perhaps destroying all of humanity. And so it's worth, even if it's a small risk, once again, a small probability, once again, the risk is so high that I'm very excited to see that NASA and ESA are combining to protect us from those possibilities. The last mission I want to talk about from ESA is the Copernicus satellite, which is set to launch in the 2020s, and now it's been funded. And what it is an Earth-observing system of 6 satellites. And why I think that's so important is it's going to monitor climate change and Earth geology and climate. And it's very important because NASA is cutting back on these things, partly because of the priorities of the current administration. And I think it's very exciting that even as the United States falls back, that at least Europe is going to launch missions that allow us to look at the Earth, monitor more carefully, and perhaps be able to assess some of those things I talked about before, those possible global tipping points, and build better models to see if those ideas are realistic or not. All of these things are incredibly exciting because every time we open a new window on the universe, as I've described, we're surprised. So it's nice to see that some people, their New Year's resolutions is to actually do something to understand the universe and potentially protect the human species, even as many of our politicians are ignoring the risks. And hopefully the public, if informed, can help all of us become better prepared for a new future, a better new year, and a better many new years. Thank you. Science matters.